Hello, welcome to Algorithms. Today we are going to discuss about Enterprise BI in Azure with Azure Synapse Analytics. In this reference architecture, we are going to discuss about ETL pipeline that moves data from an on-premises SQL Server database into Azure Synapse and transforms the data for analysis. So let's look at the scenario first. So in this case, the scenario is that an organization has a large OLTP data set stored in SQL Server database, which is on premises, and the organization wants to use Azure Synapse to perform analysis using Power BI. Let's look at the high-level architecture. So in this presentation, I am covering just SQL Server as a data source. In the future presentations, I'm going to cover Oracle and other database from OLTP to OLTP, as well as from OLTP to NoSQL migrations as well. So here we are just talking about migration from SQL Server to Azure Synapse Analytics, and it is just one SQL Server database. And as I said, the data source is SQL Server. For data storage, which is kind of staging area, we are using blob storage. For data warehousing, we are using Azure Synapse. For analysis services, we are using analysis services. For visualization, we are using Power BI. Now, the reason we are using Azure Synapse Analytics because it is a distributed system, and the organization is looking for a system which can support a large amount of data processing, and it should also support massive parallel processing, so which makes it suitable for running high performance analytics. Analysis services, they are looking for a solution which is fully managed and that provides data modeling capabilities. So using analysis services to create a semantic model that users can query, and in this case it is specifically used for BI dashboard scenario. So analysis services reads data from the data warehouse to process the semantic model and serves the dashboard queries. Okay. So currently, but this is one thing that you have to remember, it just popped up in my mind. Currently, Azure Analytics Analysis Services supports tabular models, but not multidimensional models. So the tabular models use relational modeling constructs like tables and columns, whereas multidimensional models use OLAP modeling constructs like cubes, dimensions, and measures. So if you require multidimensional models, use SQL Server Analysis Services, and that's one of the thing which I wanted to highlight. So let's look at the data pipeline. So this is a data pipeline which consists of 5 different steps. The step 1 is exporting the data from SQL Server to flat files using BCP utility, then copying the flat files to Azure Blob Storage using Azure Copy, then loading data into Azure Synapse using Polybase, and then transforming the data into a star schema using T-SQL, and then loading a semantic model into analysis services. Now this sounds very simple, means looking at this pictorial representation, it looks like a very simple architecture, but the devil lies in the details. So I would like to cover some of the recommendations for each of the step that we just discussed, those 5 steps. Okay. So let's look at exporting data from SQL Server. So if possible, schedule data extraction during off-peak hours to minimize resource contention in the production environment, and avoid running BCP on the database server. Rather than that, run it from another machine. Write the files to a local drive. Ensure that you have sufficient IOPS, input output per second, resources to handle the concurrent writes. For the best performance, you can export the files to dedicated fast storage drives. You can also speed up the network transfer by saving the exported data in gzip compressed format. But there is a catch here. Loading compressed files into the warehouse is slower than loading uncompressed files. So there is a trade-off between faster network transfer versus faster loading. So if you decide to use some compression mechanism, don't create a single file. Instead, split the data into multiple compressed files. For copying flat files into the blob storage, you first need to create a storage account in a region near the location of the source data. So these are the things which are prerequisites that you have to do prior to migration. When you are at the design phase or when you are in the discussion phase, you need to figure out these things. Where is the data source or data center, and then the nearest region. Then you deploy the storage account and Azure Synapse instance in the same region. Now don't run a Azure copy on the same machine that runs your production workload, just like we discussed about BCP, because the CPU and IO consumption can interfere with your production workload. If you are testing, that's fine, but we are specifically talking about the production systems, because we have seen production systems which are being used globally in different time zones, and some customers, they started running these operations unknowingly, and suddenly they got tickets or performance issues on the system. So tickets related to whatever systems they have, people have started raising ticket or priority 1 incident that the system is running very slow. So the advice is test the upload first to see what upload speed is like. You can use there is an option called \NC option in Azure Copy to specify number of concurrent copy operation. You can start with the default value, then experiment with this setting to tune the performance. In a low bandwidth environment, too many concurrent operations can exhaust the network connection and also prevent the operations from completing successfully. So if you are moving data using the public internet, if this is not fast enough, consider setting up an express circuit route. So ExpressRoute is a service that routes your data through a dedicated private connection to Azure. Another option, if your network connection is too slow, is to physically ship the data on disk to the Azure data center. So during a copy operation, Azure Copy creates a temporary journal file which enables Azure Copy to restart the copy operation if it gets interrupted. So make sure there is enough disk space to store the journal files, and you can use the \Z or Z option to specify where the journal files are written. So these are very important points when you are doing the actual execution from the architectural perspective. As I said, it looks very simple, but when you get into the details, you have to keep in mind about the different options at each stage and what you need to do, what you don't need to do. Create a project plan, mention all these things as a part of a checklist, that this is the checklist and I need to verify each of the things before I start the activity. When everything is done, verified, then you start with the actual migration. Load data into Azure Synapse. So you can use Polybase to load the data files from blob storage into the data warehouse. So Polybase, as you know, is designed to leverage the MPP architecture of Azure Synapse, which makes it fastest way to load data into Azure Synapse. So there is a two-step process. Create a set of external tables for the data. An external table is a table definition that points to data stored outside of the warehouse. In this case, the flat files in blob storage. This step does not move data into the data warehouse. Then you create staging tables and load data into the staging tables. This step copies the data into the data warehouse. Now, from the recommendation perspective, consider Azure Synapse when you have large amount of data. As I said right in the beginning, in this use case, we have more than 1 terabyte of data and are running analytics workload that are going to benefit from parallelism. So if you have like 200 GB data, don't even think about considering Azure Synapse because it is not going to be cost effective. And Azure Synapse is not a good fit for OLTP workloads or smaller data sets, as I said, like less than 250 GB or 100 GB or 200 GB. For data sets less than 200 GB, you can still go for Azure SQL database or SQL Server. Now creating the staging tables as heap tables which are not indexed. So the queries that create the production tables will result in a full table scale. So there is no reason to index staging tables. Okay. So Polybase automatically takes advantage of parallelism in warehouse, as I explained. So the load performance scales as you increase DWUs, data warehouse units. For best performance, use a single load operation, and there is no performance benefit to breaking the input data into chunks and running concurrent workloads. You can use Polybase to read compressed files. However, only a single reader is used per compressed file, because uncompressing the file is a single threaded operation. Therefore, avoid loading a single large compressed files. Instead, split the data into multiple compressed files in order to take advantage of parallelism. So you have to be cognizant of the limitations of Polybase. So Polybase supports a maximum column size of varchar 8000 and varchar 4000 and var binary 8000. So if you have data that exceeds these limits, one option is to break the data up into chunks when you export it, and then reassemble the chunks after the import. And we have seen a lot of customers who have exact similar scenario and things were kept failing, and then they realized, oh, this is why it is happening. Polybase uses a fixed row terminator or new line. So this can cause problems if new line character appear in the source data. You know what I'm saying? So you have to be cognizant of this important aspect as well. And your source data schema might contain data types that are not supported in Azure Synapse, and that is part of the assessment exercise. To work around these limitations, you can create a stored procedure that performs the necessary conversions. Okay, and you can reference this stored procedure when you run BCP. Or you can use Redgate Data Platform Studio that automatically converts data types that are not supported in Azure Synapse. But Redgate Data Platform Studio is not part of this presentation. So maybe in the future presentations, I'm going to cover how you perform data transfer using Redgate Data Platform Studio. Now let's quickly look at transformation of data. So you can create the production tables with the clustered column store indexes, which offer the best overall query performance. Now column store indexes are optimized for queries that scan many records, and column store indexes do not perform as well for lookups which are focused on single row. So if you need to perform frequent single row lookups, you can add a non-clustered index to table scan. So singleton lookups can run significantly faster using a non-clustered index. Those who are coming from database administration background, for them these terminologies are very easy to understand and grasp. Those who are not coming from DBA or development background, that they have jumped directly to the cloud environment, or they are relatively new to these concepts, means they have to go back and read about these things before they can start from the architecture point of view, I would say. Or it is a recommendation. You should have a clear understanding of column store indexes, lookups, how data warehouse organizes, to say Azure Synapse Analytics, what are the different ways you can store data, and what is the best performing architecture. And you have to understand the internals as well, so that you can design a best performing solution. Okay, then loading the data into semantic model. Since I explained that it is a tabular model, So you can create a semantic model by using SQL Server data tools. You can also create a model by importing it from Power BI desktop file. Because Azure Synapse does not support foreign keys, you must add the relationships to the semantic model so that you can join across the tables, and this is a very important point. Those who are new to Azure Synapse Analytics or those who have not implemented the solution, these are the points that you have to be. A lot of things are very easy. It's like click next, but some of these things are very important, because if you miss it, it's going to cause problem when you are doing user acceptance testing or functional testing. Okay, so using Power BI to visualize the data, as I said, means now this is very simple. You avoid running BI dashboard queries directly against the data warehouse. Okay, so BI dashboards require very low response times, which direct queries against the warehouse may be unable to satisfy. So, and if you have to refresh the dashboard quite often, you may need to look at other factors as well. Okay, now I guess I covered all the points from the recommendations perspective, and this is it from my side. As I said, in the future presentations I'm going to cover different use cases covering the similar tools. So there will be Azure Synapse Analytics, there will be blob storage, but rather than Polybase, I'm going to use ADF, so Azure Data Factory. So in that use case, what is going to happen, since this is one-time activity, it will be a continuous activity. So you are using a database which is on premises, it is being updated on a frequent basis. It is an OLTP database, it could be SQL Server, it could be Oracle. You are using ADF, you get data from the on-premises source system and moving it to Azure Synapse Analytics. So that scenario will be covered in the future presentation. Okay, I guess this is it from my side. Thank you very much. Have a great day.